We're going to use SOHCAHTOA, absolutely. Whenever we're dealing with trigonometry, it's a good thing to write down. I know that the three angles equal 180 degrees. In a triangle, yes, they do. SOHCAHTOA, yep. A right triangle is a 90-degree triangle, which means all angles must, so not all angles add up to 90, but there is a 90-degree angle. All three angles will add up to 180. A isosceles triangle has two equal angles. I don't even know what today's topic even is, very honest. So you can go back to the week at a glance and look here. So it's always, I'll list it out. Applied trig angles. SOHCAHTOA, yep. SOHCAHTOA. So that's not how you spell it. But yes, SOHCAHTOA is what we're using, and it has to do with triangles. Yep, SOHCAHTOA. That's an A at the end. You want SOHCAHTOA. All angles in triangle add up to 180. Okay, so good. Yeah, I think, you know, anytime you do a trig problem, if you start writing SOHCAHTOA, that will help you. Another thing you can do is just label those parts of a right triangle, find the hypotenuse, figure out which leg is adjacent and which one is opposite to whatever angle your perspective's from. That helps you set it up. So we're finishing up Unit 4. And next week we'll be reviewing and then testing on Unit 4 on trigonometry. And so this week is just, you know, we really didn't learn anything new this week. We're just applying it more to problems that you might see in real life. So your learning goal is I can solve real world problems with trigonometry. This is not new vocabulary. This is the same vocab from Monday and Tuesday, but I put it on here again because we're still using these words. So angle of elevation, angle from the ground to a point above the ground, angle of depression, the angle from a horizontal line to a point on the ground. So if you are in a location, you're looking up, that's an angle of elevation, and if you're looking down, that's an angle of depression. Okay, so this is your first interactive slide. And what I want you to do is drag the icon to the equation that represents this situation. And so our situation is that we have a sledding run. And that's what this little picture is here. This is, I can't really tell what that is. I think that's supposed to be a person on a sled. It kind of looks like, I'm not even sure. But it's 300 yards long. So this thing on a sled is going down this 300-yard long sledding run. It's going downhill. There's a vertical drop of 27 6/10 yards. So this height here for this measurement is the same on both sides. That is a perpendicular to the ground measurement, 27 6/10 yards. And we want to know what equation would be used to find the angle of depression of the run. So how steep is this? What is this angle here from the viewpoint at the top? Looking down, what is this angle of depression? And you can see we've created two identical right triangles where this is one of the measurements. You know, if we're looking at this, which of these is the hypotenuse? Which of these is a leg? Which one's opposite? Which one's adjacent to the perspective of X? We can look on this side as well. So when we are going to set up an equation and solve for an unknown angle, we need to know both pieces of the ratio. So you can see in the picture, they're giving us 327 6/10. So those are the two numbers that need to go in the ratio. Which ratio is set up the right way, and which is the correct trigonomic function. So I have 9 responses so far. I'm going to give you a couple minutes here just to think about this. You know, if you're at home and you want to write this down on a piece of paper and start labeling sides, write down SOHCAHTOA. Which of those is the correct equation? And if any of you guys want to use whiteboard markers, they already say this, I don't even know. There's whiteboard markers back there that you can use. Okay, and there's whiteboards out. See, I'm up to 14 responses. All right. So let's see. Nobody picked tangent. One person picked this equation. I think most of you picked this equation, and some of you picked this one. So 300, this is the hypotenuse. That's the shared hypotenuse between these identical right triangles. And so if you're looking at SOHCAHTOA, hypotenuse only shows up for sine and cosine. It doesn't show up for tangent. So you're correct. All of you are correct in not picking tangent. Okay, we don't have enough. This is not the correct information. But we do want to have hypotenuse, and then we want to have this number here, which from the perspective of angle X, this is the opposite leg. So opposite and hypotenuse mean we're going to use sine. SOHCAHTOA, sine. So, you know, kind of, I think it tricked you here because you say if you're trying to use like process of elimination, you're like, oh, there's two cosines. That's probably one of the cosines, but it's actually sine. Right, we're going to use this equation here, sine of x, because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and I don't have an adjacent length that I know. Okay, I'm not trying to figure that out. It's not given to me. I'm trying to find the missing angle. So I can only have one unknown, and my unknown is the angle. So I need to use, I'm sorry, the unknown is the angle. So I need to use the two side lengths of the triangle that are given. And so that's why we're going to use sine of x, and it's opposite over hypotenuse. Okay, so here we are, and we're going to actually solve this problem. For x and round, our answer to the nearest tenth. And so something you can do with these problems is go through and label things. That kind of helps. So I'm just going to use some color coding here. I'm going to use blue for my hypotenuse. I'm going to label it hypotenuse. But sometimes when you don't know where to start, this will help you figure it out. Just label everything you know, write SOHCAHTOA out, and then see what you have that you can use. The adjacent sides are here to x, okay, because it's from the perspective of whatever we're using. We are using angle x, which is here. Okay, so this is also by alternate interior angles, that is also angle x. So the green leg is adjacent to it, and these are two right triangles, so I could also put in the little right angle thing, little box. And then these sides here, these are the opposites to x. opposite leg. The green ones we said were the adjacent legs. Okay, but when I'm setting up this equation, I can only have one unknown, and my unknown is the x. Okay, that's what I don't know. But I have to use what I do know, and I know the opposite, and I know the hypotenuse. And so from SOHCAHTOA, okay, I have the hypotenuse, and I'm also given the opposite. Yeah. What happened? Probably. I don't know. That's a good question. Yeah, you don't use Chromebook usually. I'm not really sure, but I'll ask. I'm going to meet with our principal later today, so I'll ask her. I'm not really sure though. Okay, so there's the why behind why we're using this. And now whenever we're trying to find a missing angle, this is where we have to rewrite this equation as an inverse trigonomic function. So this is going to turn into something else. It's going to be sine inverse of something equals x. And that something is the ratio. So inside the parentheses, now I'm going to put the ratio. Let's change color. So when you have an unknown angle measure, this is how you rewrite it. You flip it around to an inverse trigonomic function. You put the ratio in the parentheses, and then the x, your unknown angle, becomes over here on this side. And we're going to use a calculator to do this. To find it back. There it is. So Google Calculator, when you first open it, it'll be on radians. You need to switch it to degrees. And then to get to the inverse trigonomic functions, you hit INV, and then you'll click on the one that you need. So we need the inverse sine function, which shows up as arc sine. Already starts putting a parenthesis for me, so I'm going to type in this division problem here, this ratio, 27 6/10 divided by 300, and then close the parentheses. So make sure you're on degrees, you hit inverse, you hit the inverse function that you need, which in this case is inverse sine, arc sine, and you plug in what you need from your equation, and then I'm going to hit equals, and that's going to be my answer. And we're going to round it to the nearest tenth. So 5.2. 2 is in the tenths place. If I look into the hundredths place, I have a 7. So I'm going to round this up to 5 3/10. Anytime you round, I'm going to use the wavy equal sign. Approximately equal to 5 3/10. Okay, and so that is our answer for x, and that is the measurement of the degrees, 5 3/10 degrees. This picture is not to scale. So that length of the sled ramp is 300 yards, and then that height that it's showing you of 27 yards, that's not to scale. So this would really be a much longer rectangle picture. This is a reasonable answer. Reasonable answer is when you're doing this, if you get something that's negative, okay, your angle measures probably shouldn't be negative. That doesn't make a lot of sense. It's inside of a triangle, a right triangle. So you know it would be an acute angle. It'd have to be less than 90. You guys have any questions on what we just did? Huh? Oh, why is there a -1? Okay, good question, Adriana. So that's how we write the inverse trigonomic functions. When we don't know an angle measure, we'll use inverse trigonomic functions. When we don't know a side length, we'll use trigonomic functions. So where would this be? Let me go see if I can find where it's at. Go to Google Classroom. Let's see. This was, we started learning about trigonometry in week 9. So these 2 weeks we were just kind of doing regular trigonomic ratios. Then we started doing inverse trigonomic ratios, which I think is week 11. Okay, so sine and cosine inverses was week 11. And then week 10 was tangent inverse. So you can go back to those paradox and look at the inverse trigonomic functions. That's just how you write them. That -1 represents, that is an inverse trigonomic function. And you can kind of see that on the calculator. If I hit inverse, all these pop up with a little -1 next to them, which represents why it's different. It's the inverse function. You use it when you don't know an angle measure. Great question, by the way. Any other questions? All right, so I'm going to take you guys to the next slide. It's another drag the icon slide. So we have another real life situation here. Little Susie, she let go of her balloon and it floated to the top of the gym. They did not spell out the word top, but that's what it's supposed to be. Top of the gym, 50 feet above the ground. So you can see Susie there, the balloon's going up, and that's a distance of 50 feet, a vertical distance of 50 feet. And her big brother is standing 60 feet away. That's her big brother over there. I don't know if he's holding a basketball or like another balloon. Not really sure. What equation would you use to find the angle of elevation from him to the balloon? So he is the viewpoint, and so he's looking up at those balloons, so that is an angle of elevation. Maybe it's a basketball. Maybe he's going to throw them at the balloons. I'm not really sure how that's going to help, but I don't know. It's a weird problem. And so we're going to figure out this missing angle. Anytime you're trying to find a missing angle, that's when you use the inverse trigonomic functions. And you don't go to that until you actually set up the equation with a regular trigonomic function. So we're going to pick one of these. It's either tangent, sine, or cosine of x. And then based on the perspective of that angle x, those two measurements, 50 and 60, what do they represent and how should they be put into the ratio? So one of those is correct. I'm going to give you a couple of minutes to figure it out. We're up to 11, 12 responses. I have half of you that have responded. This is a right triangle, because those balloons are floating straight up vertically, that perpendicular to the ground. So those two dimensions, 50 and 60, what do they represent in a right triangle? And which trigonomic function goes with those two side lengths of a right triangle? "13 responses. Got one more. Okay. So, looks like the majority of you chose one of the tangent trigonomic functions was set up as an equation. A couple of you picked cosine. If you look at this right triangle, 50 and 60 are the two sides that make up the right angle. They are the two legs of the right triangle. So we have to use a trigonomic function that uses adjacent and opposite. We don't know the hypotenuse, so we don't want one of the trigonomic functions that uses hypotenuse. So cosine is out. It has to be one of the tangents. But we just have to make sure our ratio is set up the right way, because you have two choices. You have 50 over 60 or 60 over 50. So from the perspective of this angle that we're trying to find, 60 is adjacent to x, 50 is opposite to x. And tangent is opposite over adjacent, so you want 50 over 60. This is the correct equation here. Okay, so everyone should move their little red dot over there. That's the first one. The top row all the way to the left. Tan of x is equal to 50 over 60. And so what you're going to do now on your practice on your own slide is you're going to solve for that missing angle. So we know that